In this video, we are going to discuss about minimax H and alpha beta pruning in artificial intelligence. First, we are going to know what is minimax H. A minimax H is a recursive or backtracking algorithm used in decision making, especially in game theory. It produces an optimal move while play the games. Minimax algorithm uses recursive to search through the game tree. Minimax algorithm is mostly used for game playing in AI, such as chess, checkers, tic-tac-toe, etc. All these are two-player games. Minimax algorithm is especially used in two-player games. One player treated as max player and another one is min player. Max player always try to get a maximum profit and minimize the benefit of opponent player. Opponent player is min player. Both players of the game are opponent to each other. Max will select the maximize value and min player try to minimize the opponent's possibility to win in the game. The minimax algorithm is carried out by using a depth first search algorithm to search for a optimal decision in the game tree. Minimax algorithm proceeds all the way down to the terminal nodes of the tree. Terminal nodes are nothing but leaf nodes. Then backtrack the evolution from terminal node to initial node, that is the root node. Pseudocode for minimax algorithm. For this, we pass three parameters. The first one is node, and the second one is depth of the node. Third one is maximizing player, min player or max player at that particular level. If depth is equal to 0 or node is the terminal node, then we return the evolution, static evolution of the node. Other than terminal node or depth 0, remaining intermediate level nodes or initial level nodes, we calculate the node value based on the type of node. If it is the max player node, then its value is obtained by selecting max of its childs. If it is a min player, we evaluate the node value as min of its child. Working of the minimax algorithm. In minimax algorithm, one player is the player 1 called as max player and player 2 called as min player. The ultimate aim of the game is max player becomes win in the game. Maximize will try to, or max player will try to get a maximum benefit and win in the game. At the same time, minimize the probability of min player to win in the game. The algorithm used depth first search to perform search in the game tree to select an optimal decision. All the terminal nodes, the terminal values are given, so we compare those values and backtrack the tree until the initial state occurs, following all the main steps involved in solving the two-player game tree. So consider the example. Here there is a game tree. Initial node is A and the terminal nodes are H, I, J, K, L, M, N, O. Intermediary nodes, that means nodes at level 1, level 2, B, C, D, E, F, G, H. The initial one is max player level. Next level is min player level. Next level is again max player level. Next level is min player level. In this way, in the decision tree, max players are alternative levels. Similarly, min players is also alternative levels. At the terminal node, it evaluates the values of terminal nodes. Based on the evaluation values of terminal nodes, all the intermediary node values are evaluated. For example, at the terminal level, the node values are evaluated as 1, 4, 2, 6, 3, minus 5, 6, 7. Its previous level is the max player level, so that it needs to maximize the values from its childs. For example, here you select node D. It have two childs, Hi. The static evaluation value of terminal node H is -1. Static evaluation value of terminal node I is 4. So now compare the static values of these two and the predefined evaluation value of node D, which is minus infinity. So minus infinity, -1 and 4. Out of these three, the max one is 4. So the D evaluation value is 4, like this. Similarly, for node E, its childs are J, K. Their corresponding static evaluation values are 2, 6. Out of these two, max one is 6, which is the evaluation value of node E. Similarly, for node F, the child nodes are L and M. Their static values are -3 and -5. Max one is -3, set as the evaluation value of node F. Similarly, for node G, its childs are N, O. The static evaluation value of N is 6 and O is 7. Sorry, N is 0. So out of these, the max value is 7. In this way, the evaluation values of nodes D, E, F, G are estimated based on the static evaluation values of their childs. Similarly, its previous level is the minimize level, the min player level. In this min player level, there are two nodes, B and C. Here, the ultimate goal is minimize the probability of opponent player winning, so that here it select the minimum estimated value of its child's evaluation values. For example, if you take B, node B, its childs are D and E. Their corresponding values, estimation values are 4 and 6. Out of these, the minimum one is 4, so that its evaluation value set as 4. Similarly, for C, the evaluation value is 3. It is the minimum of 3 and 7, which are evaluation values of node F and G. Similarly, the evaluation value of node A is estimated based on the evaluation values of node B and C. It is the max level, so that we select the max of node B and C. So It is nothing but 5. It is nothing but 4. So in this way, we can evaluate the evaluation values of nodes in the minimax tree based on the static evaluation values of terminal nodes. Once the terminal nodes evaluation values are estimated, based on this, the evaluation propagated backward up to initial node, from terminal node to initial node. At max level, the node evaluation value is nothing but max of its childs. At min level, the node's evaluation is min of its childs. The properties of minimax algorithm. Minimax algorithm is complete, means it will definitely find a solution if it is existed by perform search in the decision tree. Optimal minimax algorithm always provide optimal solution or optimal decision. The time complexity of minimax algorithm is order of b to the power of n, where b is the branching factor and NEM is the maximum depth of the tree. Space complexity is order of BM. B is the branching factor and M is the maximum depth of the tree. But minimax algorithm have some limitations. Those are the main drawback of minimax algorithm is it gets really slow for complex games to generate the decision tree because there are so many possibilities. The type of game has a huge branching factor and the player has lots of choices to decide. The limitation of minimax algorithm can be improved by performing alpha beta pruning, where while exploring the decision tree, we identify the dead ends where there is no chance for getting solution. Such type of dead ends are identified and stop their exploration. Because of this, alpha beta pruning can improve the performance of mini max search, especially the time is very less to make decisions. Okay, thank you.